Hello, good morning. I need a response in the chat if you are online. So I'll know those who are here with us. So far, I see only two people, six. Um, we have a class of about 129 on the Telegram platform. So I'm expecting a sizable number of people before I actually begin. All right. So thank you. Good morning. You can always leave an emoji for me to know that you are here with me. Um, I'm I'm trying this platform for the first time for the purpose of the class to see how it goes. So bear with me on that. And I am reading 10 people who are actually online. Yes. So that's how we're gonna go if this works for us. All right, all right, all right. I like the engagement. I like the engagement so far. So I believe my voice is audible for you all. So if my voice is audible, just say yes. Just type in yes in it. All right. Okay. So I see a lot of yeses that have been posted. Okay. Um, you can always use the chat section to also put in your questions as we move along. I will not always show my face due to maybe I'll show it and then we'll see how that goes. All right. So subsequently, we've been looking at data warehouse, and this is week 3. But then I still need to address certain parts after going through some of the prospective exams question, and as a result, I need to revisit some of the topics and then go through it with you. After doing some review, we would also have um, after doing some review, we would also have a practical session outside of the Power BI, SQL, database creation, and I'm hoping I'm able to go through that or share with you some links that will help you at least start from there. I hope my someone said my I should speak a little louder. I hope I'm still audible. If it's not audible, you can always post to let me know that it's not audible. And then I would adjust my microphone in a way that would favor everyone. Those of you who are using proxy names, those of you who are using proxy names, I would advise you as much as possible to make sure you leave your actual name, because I wouldn't know who it is. If not, I would create an attendance Google form, and then we would use that for attendance. So we'll see about that. Okay, let's box on with today's lecture. So I'm going over the concept of data warehousing, and we already know that data warehouse is a subject-oriented, integrated, time-variant, non-updatable or non-volatile collection of data used in support of management decision-making process. And we looked at subject-oriented, being that in the data warehouse, it's arranged by customers, patients, students, products, or entities that are involved in the database. And also integrated means that they have consistent naming convention where they are being formatted, encoding structure, because they are coming from multiple sources. We try to keep everything consolidated in one single form. Also, time variant means can study trends and changes, which means they are historical data that is coming from a period of time. It's non-updatable, means it only we read only as a result of the fact that it's a periodic data. We can only add, but we can't update. So we can only add to the database, but we cannot update the data that is already inside the data warehouse. Now, a data mart, which is a component of a data warehouse, is basically limited in scope because a data mart is usually with regards to a single subject area. So that subject orientedness is, you know, directed towards that particular um, subject, which will form a data um, warehouse. So why do we need to have data warehouse? To have an integrated company-wide view of high definition information. And so if you pick a company like Melcom, if you pick a company like ShopRite Game, these are um, shops, or let's say supermarkets, that have several outlets. And so a data warehouse would integrate all the various data from the various um, databases that exist at each location. Also, separation of operation and information system. In other words, trying to separate daily operations or transactional database from the database that would help us derive more information. So issues with company-wide view, there are always inconsistent key structures, synonyms, free form versus structured field, inconsistent data value, missing data. And this you could make reference to your textbook, chapter 9, with the first example that is stated there. And those are things that, for the reason why we actually address data warehouse in that uh, regard. And so, in the diagram that you would see in front of you, we have student data, employee data, student health, and you notice that there are certain information that could be missing along the way, right? And inconsistency are things that we look at and we try to resolve as a result of um, data warehousing. Now, there are things that also help motivate data warehousing. That is okay, organizational trends. So we say that there is no single system of records, all right, and then multiple systems that are not necessarily synchronized. And as a result, we bring it into a data warehouse to synchronize them. Right? Organizational need to analyze activities in a balanced way so that we can easily get more informed decision. Then building our customer relations, trying to manage our customers, knowing who they are and what their trends are. Also, we can we look at suppliers relation management. The relationship we have with our suppliers also play an integral role. So these are motivations based on organizational trends that pushes us to actually get into what? Data warehousing. Now, we talked about separating operational from informational systems. All right. So operational systems are used to run businesses on real time based on current data, right? Transactional data, etc. But informational is a system that we design to support the decision making based on historical point in time. And then we're able to predict data for complex query or for data mining application. And so we are looking at the data in terms of what happened previous years. And we're able to know that, oh, okay, this customer in a form of supermarket, this customer have this trend. You always buy ABC, and we're able to know, okay, then we can target him with this particular advertising project, which could be a link to a product that they are into. And that will be going into data mining. So data warehousing always precedes or help us with regards to um, when we want to build our or do mining in regards to data that is available to us. Then we have this table that gives us a comparison between operational and informational systems. So the purpose for operational system is quite different from the purpose for informational system. And so we say that the primary purpose for operational system is to run the business on a current basis. Whereas for informational system, it's meant for supporting managerial decision making. So when management wants to make a decision, they are inclined more to historical data, whereas the day-to-day activities of running the business will require an operational system. Now, the type of data, current representation of state of the business, and that's what we get with regards to the type of data. Whereas informational system is a historical point in time that is snapshot and also for prediction. So we're looking at historical data, right, for future trends or future activities that could be done. Now, the primary user for operational systems is the clerk, the salesperson, administrators. Whereas management, business analysts, and customers would use the informational system. The scope of usage, we are saying that the scope of usage when it comes to operational systems is narrow, planned, simple update, and queries. So simple updates and queries are being used, whereas for informational system, it goes beyond that. It's broad. There's ad hoc, complex queries, and analysis as well. Then we have the goal for operational is for performance, throughput, and availability. In other words, we want to increase performance. We want to ensure that a person can go through out with performance. And then also, it is always available to users. So whoever the users are, it should be available to users. Then we have the volume. Now, many constant update and queries on one or a few tables, right? Whereas in the volume of information systems, we do batch updates, and then the queries, we do queries on more or many or all the rows that are available, because in you realize that we want to take, you know, make a decision would require us working with a huge document. So we just don't process on just a few lines, but we could be running it on the entire data warehouse or more rows combined together. So we looked at when we come to the architectural design of a warehouse, we have several. So there is the independent data mart, there is the data mart and operational data store, there is a logical data mart and real-time data warehouse, and there's a three-layer architecture. These are the various forms of warehouse architecture that exist. Not limited to, but that is what we have. Now, the independent when we look at the independent data mart, right? We say that variety of let's look at the design of that in order to derive at that. And all of this involves the ETL, that is extract, transform before it is being loaded. So when we look at the diagram that we have ahead of us, which is the independent data mart architecture, all right, which was espoused by Ralph Campbell, right? There are several ways that we go through before or in building the architecture. So the first thing is that data are extracted from the various external and internal source, right? Which is the first block you see in front of you. All right. So in a large organization, there may be dozens or even hundreds of such files in a database. Then the next thing we do is that the data from the various source of system are transformed and integrated before being loaded into the data mart. So transactions may be sent to the source system to correct errors discovered in the data staging period. The data warehouse is considered to be the collection of what? The data mart. Now, the third thing is that the data warehouse is a set of physically distinct database organized for decision support, and it contains both detailed and summary data. All right. Then the fourth part is that users access the data warehouse by means of a variety of query languages or analytical tools. That's when they get results. So the prediction forecast may be fed back to the data warehouse and the operational database. Now, each of these data marts are limited in scope, and there is no centralized data warehouse. Thus, they do not give the overall picture of the entire organization. However, they are typically easier to build than a full-fledged enterprise-wide data warehouse. So, because of these problems, there is a debate about the usefulness of an independent data mart. Although Campbell espoused this approach, there are others that find fault with it. All right, and so there are limitations, and here we see the limitations that is being outlined. We say that separate ETL process for each of the data marts, right? And so which means there's redundant data and process because some data, some data might be repeated in other independent data marts, right? Then inconsistency between the data marts, inconsistency between the data marts, and that could cause a lot of problem with duplication. That is not something we want. So difficulty to drill down for related facts between data marts. What we are saying are there are two or more data marts, all right? How the independent data marts are related. That would also be difficult because each of the data marts are independent. Also, we look at excessive scaling cost are more what applicable applications are built now. When we've thrown and have separate mats, that will definitely influence scaling. When we want to rebuild some, because we have separate, we're going to spend more, right? Then there's high cost for obtaining consistency between the mats. See, instead of doing the same thing that will cover everything, you have to duplicate or replicate consistency on each of the various mats that you would have available to you. And that is something we want to avoid. So we have the next which is the dependent data mart width. It looks like the color codes you guys have there. So the dependent data mart with store, that is a three-tier architecture. Right. So let's look at so in the case of the dependent data mart, there is a centralized worldwide data warehouse, and the data marts are loaded from the enterprise data warehouse. So the enterprise data warehouse is centralized, where it integrates the data warehouse, serving as a control point and single source of all data made available to end users for decision support application. The data mart approach is called a hub and scope architecture. Another term that is used is the corporate information factory. And Bill Eno, another famous data warehouse pioneer, is an advocate of the centralized approach. I have to note that the operational data store, right, where that is in the diagram, which is integrated, subject-oriented, continuously updatable. It's what? Current valued in recent history. Then we have the worldwide, we have the detailed database designed to serve operational users as they do decision support processing. So you see that in there, and then you have the logical data mart and real data warehouse architecture. So the logical data mart is not a physically separated database. Rather, it is created by a relational view of the data warehouse. Remember the concept of a view, right? If in your database, when we talk about a view, right? Yeah. So the notion of a real-time data warehouse means that the source data system, the decision support service, and the data warehouse exchange data and business rules at a real-time pace. This helps to give a more current, comprehensive picture of the organization. I hope that is clear. And then the other thing is that the logical data mart and real-time data warehouse architecture is practically only or for only modernized sized data warehouse or when using high performance data warehouse technology. Right. So the difficulty with this approach system forms from the attempt in keeping the data warehouse current, which requires more or less continuous process. So there are a lot of difficulties when it comes to this, right? So, I mean, a few advantages that we can look at is that new data mart can be created quickly, but no physical database or data technology needs to be created and acquired, and no loading routine need to be written. In other words, we don't, once they are created, we don't repeat them. In that. So secondly, the data mart are always up to date because data in a view are created when the view is referenced. So a view can be materialized if a user has a series of queries and analyze that need to work off the same instantiation of what a data warehouse. So we look at the difference between a data warehouse and a data mart. And in that regard, you'll notice that with regards to scope, a data warehouse is application independent. It is centralized, possibly enterprise-wide, and it's planned. Whereas for data mart, it is scope based. In other words, it's specified. It deals with one particular thing. It's organic, probably not planned. So you can go through the table to see the difference. And the data in the data warehouse is mostly historical, detailed, summarized. It is likely denormalized. In other words, it has been processed and structured in a way that we want it for a data warehouse. In the data mart, it's somewhat, there has some history detailed, summarized, and it's highly what? Denormalized. With regards to subject, a data warehouse has multiple subjects, whereas um, the data mart is one central subject that concerns users. The source for data warehouses from many places, right? That is for um, data warehouse, whereas in a data mart, it is few internal and external source. And then we have the other characteristics would be that data warehouse is flexible, data oriented, long life, large, single complex structure. whereas the characteristics for data mart is restrictive, project um, project oriented, short life. Start small, becomes large. It is multi or semi complex structure. So we have this the diagram showing an example of a three-tier or three-layer data architecture for a data warehouse. Right? And so we see the relation between the entities that have been provided. So this we have the operational data that are stored in the various operational systems of record throughout the organization. Then we reconcile data as a type of data stored in an enterprise data warehouse and an operational data store. So reconcile the data are detailed, current data intended to be what? A single authoritative source for all decision making. And then the derived data are the type that the data stored in each of the data marts. So derived data are data that have been selected, formatted, and aggregated for end user decision support application. Now, each of these involves metadata geared to the particular need. So for the operational system, the metadata is geared to the day-to-day transactional operation of the business. Sometimes it may not be of good quality, especially for decision support purpose. Now, the enterprise data warehouse, that's the EDW, metadata includes rules for extracting, transforming, and loading operational data onto reconciliation data. And the data metadata describes the derived data layer and then the rules for transforming reconciled data to derive what? Data. We have the data characteristic status versus event data. All right. So this is the characteristics of the data warehouse are different from those that are of what? Operational um, database. So here we see the distinct between the status and then the event data. Status would typically be stored in the what? Operational database as a result of transactions. So transactions will cause changes to the data over time, as we see in the example. But the fact that the transaction itself is not stored in the database, right? It is, however, recorded in a database log. Sometimes it is important. Sometimes this is important information for data warehouse, the log. For example, we may want to know how many transactions are taking place or when they take place. Subsequently, the log data is often part of what gets loaded onto the data warehouse so that we are able to know that transactional information. And then we see the data characteristics with transient and what? Periodic. And this is another distinction between transient and periodic what? Data. Operational data is typically transient. When a record changes, the old data is not maintained, but is replaced with a new data. For example, in the case of row 2 in change, its old data is lost when row 4 is deleted, right? The old data is also lost. However, for data warehouse, which is time variant, maintaining historical data is very important. So those are some of the difference we look at. This slide shows periodic data. Note that in this case, all data is not removed. Rather, it is kept in a data warehouse to maintain a historical record. We have added two columns. One shows the date at which the action was done. The second is the action itself. So we've added some logs. So this action could be create, update, or delete. Thus, the data warehouse do not just include data. It also includes what? Historic of what transaction that created, modified, and removed what? The data. So here we get access to know what exactly went on. So we have whatever that we did, whether it was deleted, it was updated, created, we get all those details in the data warehouse. So other data warehouse changes. So new descriptive attribute, new business activity attribute, a new class of description action, descriptive attribute become more refined. Descriptive data are related to one another, and then new source of data could also be correct. Derived data, we when we look at derived data, what are the objective for derived data? Easy of use for decision support application, fast response for predefined user queries, customized data for particular target audience, ad hoc query support, and then data mining capabilities. These are the objective. And when we look at the characteristics, they are detailed, aggregated, which means they are summarized, and then distributed. Distributed means to the various departmental servers. All right. So when we look at this, right, these are tables that we could look at. Um, let's see which dimension. Okay. So here, the first is a star schema is a simple database design in which the design are separated from fact or event data. Another name for star schema is also a dimensional model. So the star schema is composed of fact and dimensional tables. Note that the fact table is an extension, an essence, an associative entity that joins various dimensional tables. The dimensional tables are usually the source of attribute used to qualify, characterize, and summarize facts in queries, report, or graphs. Thus, the dimensional data are usually textual and discrete. Fact tables contain factual or quantitative data. And when we talk about quantitative data, we are looking at measurements that are numerical, continuous, valued, and additive about the business, such as the units sold, orders booked, and so on. Right. So the facts table surrounded by three-dimension table. Right. Each fact shows sales that are particular product from a particular store during a particular time period. So the data in the fact table was likely derived from operational database sales data. Note that This is summary data. The operational database has records of each sale, but here we are getting a summary where we are getting the unit sold, dollars sold, and dollar cost. This is typical in data warehouse and has to do with another concept we're going to focus on. That's the concept of granularity. Granularity. Yes. So we will be seeing that. We'll be looking at that subsequently. All right. So here, this is also a star schema showing the data. Notice that the fact table has numerical data and foreign key. The dimension table has a primary key and a discrete data. The question is, let's ask a question about this table. What can you say about units sales for store S2? Store S2. Yes, in the comment section, let's see. You have the screen. So what can you say about unit sales for store S2? So look at store S2. All right. When you look at store S2, what can we say about store S2? Yes. I'm waiting for some comment. You would have to read the 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 table well in order to be able to get information. All right so let's see. So when you look at I'll be posting the facts there so that you get to see in the chat section. So this is what we can derive from the store S2. So when you check store S2, I've posted it there. So let's look at let's look at what we have there. So when you pick, you would see that when you pick store S2, right, the store name is Builds and it's located in Portland, right? But then when we come to sales, we check sales where store is. Realize, see, that's the primary key is linked to sales as a foreign key there. And then we're able to pick that. There are 50 units sold, right? For product code 128. So if you notice 50 units of product 128, right? But what kind of product is that? Then when we go to the product table and we check product 128, that's globes. That's why in bracket we've written globes. And then there is also what? At the bottom there for product one, sorry, sales code 100, that have to do with S2. We have 30 products sold of sweaters based on the product code, right? That is there. And these were sold in what? When we check the code, that is sales period, both are 003. That is 003 in the year 2010. 003 is 2010. Month would be what? June, because that's the sixth. The sixth month would be June. So by just looking at this, right, we are able to translate the star schema that we have there and then get the appropriate information from the entire star schema that have been given to us. I hope we understand it. So if you understand how I read it, please just write in the comments section um, understood, right? Or yes. Put a yes there with an emoji for me to know you are following and you understand how I was able to decipher the information with regards to store two, because I would be giving you um, a work to do in relation to that to derive um, information about a product or a store with regards to. All right, so I'm reading a lot of no there, but Asiedu seems to have understood it. All right, so please pay attention. Pay attention. So I explain it again. So the question is that we want to know, or what can we say about unit sales, the unit sales for the product, sorry, for the store S2. All right. So we want to get unit sales for the store S2. So we need to be able to link store S2 to the sales product and then a period. And by doing so, we're able to understand the relations between the four tables that have been put there. So the first thing we need to identify is that store S2. What is store S2? Store S2 is Bill's store that is located in Poland with the telephone number 943-681-2135, and the manager is Thomas. We know information about the store, but our interest is in the unit sale. So it means that we have to make reference to store 2 in sales table, in the sales table. So when we go to the sales table, our interest is to identify store 2 or store S2. So now at S2, so we have S2, and then we are now going to try as much as possible to identify the relations between store S2 and then sales. So when you check in the sales table, at the third column, you have the store code. Now, the store code we are interested in is S2. If you identify that, there are two S2s in that particular table. If you can see the two identification in sales, leave in the comment section yes, or you can just type the S2. If you see it, just write S2, all right, so that I know you are following. And then we would trace it to the other tables. Your course rep is here and he has no idea we're having a class on YouTube. So you guys can deal with him later. Okay, so let's continue. Now we've seen S2 there. So in that regards, now, so when we check sales table, right? I'm not getting the cursor. That's why I'm not using the cursor. I wish I could get the cursor to work for you guys because the app that I'm using is not allowing me have a cursor. So subsequently, I'll try and use the cursor, and then we can go on a short break, and then I would resume. Right. So I'm giving you just 5 minutes short break. I'll resume. Right, and then would continue to decipher this. So that I'll connect an external monitor and then use the cursor to demonstrate as some of you are. My screen is not dark here, oh, so please, if yeah, I'm on. I gave you guys a small. All okay. Let me go for it, and I think I would set the external screen up, and then we would together we would work on that. Right. So I would be able to use the cursor for you guys because I think that is needed so that it becomes easier to explain it. Because I might be ending here for today, and then we'll continue. So I'll come back to that diagram soon. Surrogate keys. Now, dimensional tables should be surrogate. That is non-intelligent and non-business related because business keys may change over time, helps keep track of non-key attribute values for a given product. Surrogate keys are also simpler and shorter. Surrogate keys can be the same length and format for all the keys. Grain facts. So, granularity fact of the table. Right. So, let's look at that. The term grain refers to level of details in a fact table. That the term is determined by the intersection of all the components of the primary key. So this includes foreign keys and other primary keys. Then, now, it is recommended to use small grain possible. given limitation of the data mart technology. All right, so duration of database, natural duration is 13 months to 5 quarters. Financial institutions need longer duration. Older data is more difficult to source and then what? Clean. In other words, when you are feeding, you don't need too much of an old data. That's difficult to work with. So it's we hope we are all here. All right, good. Then we have the size of the fact table that is dependent on the dimensions and the grain of the fact table. The number of row is equivalent to the product of numbers of possible values for each dimension associated with the fact table. Right. So an example here, we have a total number of stores, 100. Total number of product is what? 10,000. Total number of period is 24. That is 2 years worth of monthly data. So the total rows would be 100 times 5 active products times 12 months, which would give you what? 120 million rows. That's a lot, right? Yeah. So that is what we are looking at with regards to. Now, let me try and go back to the diagram I was showing you so that we are able to decipher that. Okay, let me share the screen with you guys. Move away from. Screen two. All right, so good. I believe you guys can see the new screen I've just shared now. So let me. All right, good. So now let's explain this. Please, if you can see the screen and see the laser, write yes in the comment section. Write yes in the comment section so that I would know we are all on the same page and I can explain this. And then hopefully we could pause for today and then we would continue with the continuation will be subsequently. All right. All right. Good. Please, again, if there are two of you using the same machine, You have to alert, you have to put your details in the chat section. If you cheat, I would know. If you don't cheat too, I would know. So now we can all see. So, like I was saying, um, our interest is in this section. The question is on S2, right? So S2 is our interest, but we need to be able to trace S2, right, to sales, right? So now when we check sales, we notice that there are two instances of S2 that is there. There are two instances of S2. The question was, what can you say about unit sales for store S2? And we want to pull the information from the schema and get the correct data. You remember I I gave you the solution. So now that we know there are two instances of store S2, now the unit sales here, right? Let me change the color. The unit sales here is this. We have 50 and then 30, representing the unit sales for S2. But unit sales for what exactly are we looking at? Unit sales for what exactly are we looking at? In this case, we notice that the product is 125 and then 100. So in store S2, we have two different product sales. What are the products? Then we refer to the product table, and then we come to know that at here, product 125 and product 100 is gloves and sweater, respectively. In other words, we've come to know that store S2 bought two products. So the first product we know is 50 units of product 125, which is gloves. And then they also bought 30 units of product 100, which is what? Sweater. Then the question is, at what time did they buy it? They could have bought it at two different times or at the same time. Then when we check on the period code that have been used, they are the same. So at store S2, two products were actually sold, where we have gloves being 50 units and sweaters being 30 units, were all sold with the same period code 003. So what is 003? This is 003, right? Now, this is 003. So 003 is this period where we've come to see that it is in the year of 2010, first quarter, sixth month, which is the month is basically 6 months is June. So on June or during June 2010, 50 units of gloves and 30 units of sweaters were sold at store S2. That is how we go. I hope the explanation is now clear. If the explanation is clear, please leave a thumbs up in the chat section for me to know indeed you are good and the explanation is clear. All right, that's good. That's good. That's good. That's a very good feedback that I'm getting. That's a good feedback. And so understanding this is important, especially with the diagram. And so there are other questions that we can ask. All right. So this diagram is figure. Please write this down. The diagram you see there is figure 9.11 or 9-11 in the textbook that you have. Now, there are two questions I would want you to answer. There are two questions I would want you to answer, which I would be um, posting in the chat sections, or you can write it down. Which store sold shoes and when? So the question is, which stores which stores sold shoes and when? The next question is, which time period has the most total dollars sold? So I've pushed the question to you. You should get it in the chat section. Write it down. Which store has the most total dollars sold? Which store has the most total sold? So yeah, so that is, you have that on your screen. Um, so the two questions are there. You have it on your screen, which is which store sold shoes and when? The next one, maybe I should retype it well because the and you have the first question, which store all right, so we have that. And all right, so we have these two. Yes, the video will be available on YouTube for you. I think that's what that's why I decided to do this. You have access to it. So you have those two questions, and that would be your. Now we would continue. All right, we would continue in the next class to look at some of the other components or schemas and how we would be able to also work our way around it. From multi-value dimension. We'll be looking at variations in the star schema, and then also the essential rules for dimensional models, and in the future of data warehouse integration with regards to big data and analytics. So I hope this was okay. Um, each one is to subscribe to the channel, and then um, check. We will. I think this will be a very good platform for us to get more involved with regards to the online lecture. And please, I don't know if you have access to the V class. If you don't, please go to the ITS and ensure that you have gotten access to that, so that we would see how best we would get the best of the lecture. Thank you all very much, and I'm hoping that we'll meet again in the next lecture, which would be, I think, when is the next lecture again? All right, so see you guys next in the next tomorrow. I think Thursday. See you guys, and then we would see how best. Now the assignment I've given you, please write it and then submit it. You're going to submit it, so you'll be submitting it through the submitted portal I've given you. So I'll give you an option, a place where you can actually type the answer there in the submission window. So that will be that. See you guys tomorrow. Thank you. And tomorrow at 3 p.m. Yes, same time, same place. We shall meet. Um, thank you very much. We'll continue on Telegram